Now we'll be looking at addition and multiplication table for modular arithmetic. Now the first question you're going to consider is we have to construct an addition and multiplication table for mod 4. Now mod 4 has the values of 0, 1, 2 and 3, of which 4 is not part. So to construct the table, let's start with the addition. So 1, 0, 1, 2 and 3. So we have 0, 1, 2 and 3. So we have this for the addition, and now for the multiplication. For the multiplication, we have 0, 1, 2 and 3. 0, 1, 2 and 3. Now all the values we are going to insert in these cells here should be any one of this. It shouldn't go beyond 0, 1, 2 and 3. So the answer we are going to fill inside these boxes can be either 0, 1, 2 or 3. So let's start. 0 plus 0, so we are working under mod 4. 0 plus 0 is 0, and 0 mod 4, 0 mod 4 is still 0. 0 plus 1 is 1, and 1 mod 4 is still 1. 0 plus 2 is 2, and 2 mod 4 is still 2. 0 plus 3 is 3, and 3 mod 4 is 3. 1 plus 0 is 1, and 1 mod 4 is still 1. 1 plus 1 is 2, and 2 mod 4 is 2. 1 plus 2 is 3, and 3 mod 4 is 3. And 1 plus 3 is 4, and 4 mod 4. 4 mod 4. How many times will 4 go into 4? 1 remainder 0. So we have 0 here. Unlike the number basis where you write the quotient and the remainder, but for modular arithmetic, we write only the remainders as our answer. 2 plus 0 is 2. 2 mod 4 is 2. So this what happens. 2 plus 1 is 3. 3 mod 4 is 3. 2 plus 2 is 4. 4 mod 4 is 0. 2 plus 3 is 5. And 5 mod 4 is 1. 3 plus 0 is 3. And 3 mod 4 is 3. 3 plus 1 is 4, and 4 mod 4 is 0. 3 plus 2 is 5, and 5 under mod 4 is 1. 3 plus 3 is 6, and 6 under mod 4 is 2. So you can clearly see that all the values here can be seen here. And again, you can also see that when you draw a diagonal, you can clearly see that it is commutative, because we have 1 here, 1 here, 0 here, 0 here, 3 here, 3 here, 2 here, 2 here, 1 here, 1 there. So when you draw a diagonal through the, when you draw a principal diagonal from the top left corner to the bottom right corner, you can clearly see that it is symmetrical. And since it's symmetrical, the table here is commutative. Now let's look at multiplication. 0 times 0 is 0, and 0 mod 4 is 0. 0 times 1 is 0, and 0 mod 4 is 0. So you can clearly see we have everything 0 here. 1 times 0 is 0, and 0 mod 4 is 0. 1 times 1 is 1, and 1 mod 4 is 1. 1 times 2 is 2, and 2 mod 4 is 2. 1 times 3 is 3, and 3 mod 4 is 3. 2 times 0 is 0, and 0 mod 4 is 0. 2 times 1 is 2, and 2 mod 4 is 2. 2 times 2 is 4, and 4 mod 4 is 0. 2 times 3 is 6, and 6 mod 4 is 2. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6, and 6 under mod 4 is 2. 3 times 3 is 9. And 9 under mod 4 is 1. 9 mod 4. 4 goes into 9, 2, remainder 1. So that's it. So let's check whether it is symmetrical. So let's draw a principal diagonal and see whether it is symmetrical. We have 2 here, 2 here, 3 here, 3 here. 2 here, 2 here, 0 here, 0 here, 0 here, 0 here. Yeah. So you can clearly see that addition and multiplication here are commutative under mod 4 and it is symmetrical. Now let's consider this question. You have to construct an addition and multiplication table for mod 6. You have to use your table to evaluate this problem, and you have to find the true set of this, and these few problems. So we have this wonderful question here. Now under mod 6 we have the values of 0, 1, 2, 3, 4 and 5. So per how we did the first one, we are going to do the same thing. So 0 plus 0 is 0, 0 under, so we are working under mod 6 for these two tables. So 0 under mod 6, so we have 0, 0 plus 1, so we have 1, 2, 3, 4, 5. Because 0 plus any number here will give us an answer that's less than 6. Now let's go. 1 plus 0 is 1, 1 mod 6 is 1. 1 plus 1 is 2, 2 mod 6 is 2, 1 plus 2 is 3, 3 mod 6 is 3, 1 plus 3 is 4, 4 mod 6 is 4, 1 plus 4 is 5, 5 mod 6 is 5, and 1 plus 5 is 6, 6 mod 6 is 0. So you have this thing in order. I think the difficult one is going to be, let's say 5 plus 5 is 10, 10 mod 6, 6 goes into 10, 1 remainder 4. So this is going to be 3, we have 2 here, we have 1 here, we have 0, 1, 2, 3, and we have 2 here, we have 1, we have 0, and we have 5. From here we have 2, 3, we have 4, and we have 3, 4, we have 5, and we have 4, 5, and we have 0, and we have 5, 0, and 1. Now when it comes to the multiplication to 5 times 5 is 25, 25 mod 6, 6 goes into 25, 4 remainder 1. I think these are the, let's say 5, 4, 3, 2, and we have 0, because all the numbers here times 0 will give you 0. All the numbers here times 0 will give you 0. We have 1, 2, 3, 4, 5. Because 1 times any number here will give you an answer less than 6. 2, we have 2. 2 times 2 is 4. 2 times 3 is 6. So we have 0. 2 times 4 is 8. So we have 2. 2 times 5 is 10, so we have 4. So we have 3 here, we have 2, we have 0, 4, and we have 3, 0, and from 3 we have 3 here, and we have 3, 2 is 6, so we have 0, 4, 1 is 4, 4, 2 is 8, so we have another 2. So this is the result. Now let's go to the real problems. The first problem is 2 plus 4 plus 3 plus 4. Now 2 plus 4, the answer plus 4 we had 0, and 3 plus 4, we have 1, and 0 plus 1 is 1. So the answer to this problem is 1. That's for the A. Now let's look at the B. The B is 3 times 4 plus 4 times 4. 3 times 4 is 0. And 4 times 4 is 4. And 0 plus 4 is also 4. The next problem, we have to find the truth set. So the first truth set we have to find 3 plus n equal 2. That's alpha. So the question is 3 is being added to a certain number and the result is 2. So you are going to stand at 3 and look at where 2 is. On this line, 2 can be seen here. So 3 plus what number gave you 2? 3 plus this number gave you 2. So you see that 3 plus 5 is equal to 2. So therefore, the question says find a truth set. So n is such that n is equal to 5. Now let's look at the next problem. Beta. That's 2 plus n equal 0. So you stand at 2 and look at where 0 is. 0 can be seen here. So 2 plus what number is giving you 0? 2 plus 4 is giving you 0. So 2 plus 4 is giving you 0. So therefore, n is such that n is equal to 4. The next question is theta. Theta is saying that n plus n is giving you 4. So what is n? So we are going for we go to the addition table and look for the certain number n that is being added to the same number n which is giving you 4. So you are going to look for 4 from the table. Now from here we can see 4. This 4 is coming from 0 plus 4. We want n plus n. We want the same number, 2 equal numbers. So we don't like this. So we are not picking 0. We can see 4 here too. That's 4 here is coming from 1 plus 3. So we don't like this. We can see 4. 4 here is coming from 2 plus 2, which is 4. So we can pick. So 2 is part. So we say that n is such that n is equal to 2. So let's go to the next 4. The next 4 can be seen here. And it's coming from 3 plus 1. So we don't like this. The next one is coming from this 4. And this 4 is coming from 4 plus 0. We don't like. Now the last 4 is here, which can be seen from 5 plus 5. So n is 2 and you can say n is also 5. So these are the only 2 instances whereby we had 4 to be our answer. Now the next thing we'll consider, that's alpha I. Alpha I is saying that n times n is giving you 1. N times n is giving you 1. So we are going to the multiplication table and look for the values of n that is giving us 1. We can see 1 here, and this 1 is coming from 1 times 1, which is true. So we say that n is such that n is equal to 1 for the first instance. Now let's look for another one again. We don't have 1 here, we don't have 1 here, we don't have 1 here. We have another 1 here. And this 1 is coming from 5 times 5. So n is 1 and n is 5. So these are the only 2 numbers. These are the only 2 numbers that can get us 1 under the multiplication table. The next one is n times 5 equal 3. N times 5 equal 3. So we'll be looking for the number n that when you multiply it by the same number n, the answer you get when you multiply it to 5, you get 3. So under the multiplication table, so let's look for the values of n that is giving us 3. Now the n times n we had, so we had 1 and 5 for the n times n, which gave us 1. So we don't like that one, which means they are not part. So we'll consider 2, 3, and 4 and see. Let's look at 2 times 2. 2 times 2. 2 times 2 is giving us 4. And let's look at 4 times 5. And 4 times 5 is giving us 2. No, we want 3. So 2 is not part. Let's look at 3. 3 times 3 is giving us 3. And let's look at 3 times 5. And 3 times 5 is giving us 3, which means 3 is part. Let's look at 4. 4 times 4 is giving us 4. and 4 times 5 is giving us 2. So the only number that can satisfy this problem is 3. So n times 5. So the answer to this problem, n is such that n is equal to 3. That's for this problem. Let's look at the last one. N times n plus 4 equal 1. So we need a number that when you multiply it by the same number, the answer you get when you add it to 4, you get 1. So let's look for 1. So let's try with 0. 0 times 0 is 0, and 0 plus 4. 0 plus 4 is 4, which is not true. Let's try with 1. 1 times 1 is 1, and 1 plus 4 is 5, which is not true. We want 1. 2 times 2 is 4, and 4 plus 4 is 2. So 2 is not part. Let's look at 3. 3 times 3 is 3, and 3 plus 4 is 1, which means 3 is part. So the answer to this problem, n is such that n is equal to 3. Now let's look at 4. 4 times 4 is 4, and 4 plus 4 is 2. 4 is not part. Let's try 5. 5 times 5 is 1, and 1 plus 4 is 5, which is not true. So the only number that can satisfy this condition is when n is 3, because when n is 3, 3 times 3, we have 3. This is the answer, 3. And 3 plus 4 is 1, which means 3 is the only number that can satisfy this condition.